Hello everyone and welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today as we begin a brand new unit on algebra. Now this set of lessons is designed for a pre-algebra classroom, which means that we're looking at ideas that lead up to algebra. What's really cool about this particular unit is it really lays down some foundational skills that we're going to use all year long in an Algebra 1 classroom. And in fact, this is really sort of a transition lesson that prepares us for how math operates in high school or in higher level courses. So I really enjoy this curriculum. I actually teach an Algebra 1 class as well. So it's fun for me to kind of see how students begin to make that transition in their thinking from very literal, concrete mathematics to more abstract and idea-based mathematics. Now we have a lot to cover today. We're going to talk about some things that you have probably seen before. We're going to clarify some ideas for you that you may have, and we're going to talk about how we can use generalization to solve problems that would be more complex than we would be able to solve using just very literal computational mathematics. If that seems overwhelming, don't worry about it. We're going to take it slow. We're going to go through this piece by piece, and we'll get there together, okay? So let's get rolling. Here's how number sense progresses. If you were in first grade, you might have been given a problem like this. 5 plus 5. Now in your head you're probably thinking, oh, that's really easy, why are we talking about it now? But just know that, that I'm doing this for a reason. And hopefully you were able to add that together at this point and come up with the number 10. No big deal, right? Or as you progressed, you might have something like 3 plus 3 plus 3 plus 3. And more than likely now, as a pre-algebra student, you're able to do that with some kind of mental math, and you're able to come up with 12. Still no big deal? Cool. Try this. 8 plus 8 plus 8 plus 8 plus 8 plus 8. Again, that might be a challenge problem for a first grader, but certainly as a pre-algebra student, you ought to be able to work that out pretty quickly. If you can't, you can pause the video to give yourself more time, but I'll go ahead and tell you that the solution is 48. Now, here's where we begin to see transitional thinking in mathematics. As a third grader, you begin to talk about different ways to represent numbers. For example, if I have 5 plus 5, this is not the only way to come up with 5 plus 5 equals 10. There are other ways for us to think about this information and to group it differently. For example, even though when I gave you the problem the first time, you knew that 5 plus 5 equals 10, some of you may have thought of it differently. You might have thought of it as 2 5s. If I have 2 5s, well, 2 5s is 10. And as a third grader, hopefully that's the way your teacher began to teach you about multiplication. This idea that multiplying is just a way of fast adding. For example, most of you probably did 3 plus 3 plus 3 plus 3 in your head, but a few of you may have realized that that's just 4 3s, and you may have used multiplication in order to figure out that that was 12. And I'm willing to bet, even though I wrote this third problem as an addition problem and asked you to add those together over here on the left, that very few of you actually sat down and said 8 plus 8 is 16, plus 8 is 24, plus 8 is 32, plus 8 is 40, plus 8 is 48. Most of you probably did not do it that way because most of you realize that this is just 6 eighths, which is 48. You see, we learn that multiplication is fast adding. And fast adding allows us to shorten the amount of space it takes for us to write these problems. And if we memorize our multiplication facts, we're able to actually solve this much more quickly as well. Instead of having to add 5 times, I just need to know one multiplication problem. What does that mean for us as algebra students? Well, fast adding can also be done with variables. Variables, you'll remember, are numbers whose value is unknown or that can change, and they're usually represented by letters. So, as an arithmetic expression, I might give you 8 plus 8 plus 8 plus 8 plus 8 plus 8, and you might think 6 eighths, which is 48. But algebraically, I might give you something like this. A plus A plus A plus A plus A plus A. Notice I'm adding 1, 2, 3, 4, 5, 6 numbers together, but I don't know what those numbers are. These could be 8s, like over here on the left. They could be 2s. They could be 3s. We have no idea. These could be anything in the world. And this is why algebra seems confusing to a lot of students. It's this idea of, how do I add letters together? I can't really add a letter. I can only add numbers. But once we realize that these are just numbers I don't know, then I can begin to use the same rules I was taught in 2nd and 3rd grade to take this algebraic expression and say, hey, even though I don't know what A is, I do know that adding 6 of them together is the same as saying 6 times that number. And a lot of times in algebra, we don't even bother writing the parentheses. We write this as the algebraic expression 6a, or 6 times whatever a is. Now, if you're struggling with that, this is a great time to pause the video and think about that just a little closer. I went through it pretty quickly because I think most of us are probably pretty comfortable once we see it explained that way. But you want to make sure you understand this, because everything else we do in this unit is designed around this idea. There are patterns that exist in numbers, like this definition of multiplication. Adding 6 things together is the same as having 6 of them and multiplying them together. I can use those patterns even though I don't know what the number is. And as long as I use the patterns correctly, the value won't change. So if A was a 3 and I were to add 6 3s together, I'd get 18. 6 times 3 is also 18. This, and this all have the exact same value. Tell you what. Maybe you can try it with this. We have some numbers here. We want to add those together. We don't know what they are, but this time I'm using the letter N. I can use any letter I want. A lot of times we pick N for number. A lot of people like to use X because of some things that show up in graphing. Some people use A. It really doesn't matter what the letter is. The important thing is we want to be able to take those letters or that expression with variables, and we want to be able to write it in a shorter way. Can you pause the video and come up with the simpler or shorter expression that means the same thing as this? Hopefully you've had time to work that out, and hopefully you realized when you counted those up that there are 13 of them. 13 times n is sometimes written as 13n. Much, much shorter. Notice how this takes up way less space, and it also includes only one operation, one multiplication, as opposed to having 12 addition signs. Now, if you're comfortable with that, we can talk about all the different possibilities that come up as a result of understanding this idea. For example, if I were to give you m plus m plus m plus m plus n, you should be able to tell me that that is 5m. Not too bad, right? How about this one? If I give you 3x's and 5x's, do you know what that means? It might seem a little harder to you at first, but really this isn't a whole lot worse, because if I have multiplication 3 times x, and I have multiplication 5 times x, well, 3 times x just means I have 3 x's added together. And 5 times x just means I have 1, 2, 3, 4, 5 x's all added together. If I have 3 of them and 5 more of them, how many x's is that? Well, that's 3 plus 5, or 8 x's. 8 x's. Can you think of a shortcut to go from here down to here without having to write all this stuff in the middle? That shortcut is very valuable. 3 x's and 5 x's means I have 3 and 5 of them for a total of 8. Can you do this one? If you need more time, pause the video. I'm going to keep right on going. I know I have 4 n's, and I have 7 n's, and I have 3 more n's, and I have 1 more here all by itself. Notice I didn't bother writing the 1 since there's just 1 of them. This means I have n plus 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 n. I'm losing track. It's going to be much easier for me to just look at this and say, oh, I have 4 of them, and 7 of them, and 3 of them, and 1 of them. Or I have a total of 15 n's all added together. You see, our ability to combine these like terms in algebra is dependent on the fact that we realize that this is 4 n's added together, 7 n's, 3 n's. As long as I realize that this is just counting how many n's are added together, then I can simplify expressions fairly easily. Tell you what, try that one on your own. Pause the video if you need a second to do that. I'm going to keep right on going because I think at this point you're probably getting the hang of this. I have 9 a's added together and 8 more. That's 17, plus 4 more is 21, plus 5 more is 26, plus 1 more is 27 a's. 27 a's. Now, more than likely, you are not going to take the time to write this out every time. Most of us are going to do this with mental math. We're just going to say 9 of them, 8 of them, 4 of them, 5. We're going to add them all together and just realize that it's 27 a's. I put this in here for our notes so that you can see mentally what's going on, but probably I'm going to do this in my head. There's a second reason I do this, and it's to help you understand that if I have 9 a's and 8 a's and 4 a's and 5 a's and 1 a, I can put all those numbers together and just say I have that many a's. This is a property known as the distributive property that we're going to talk about in a couple days. So it's nice for you to have at least seen it a couple of times ahead of time. Whew. Are you okay with that? Good, because there are actually 2 or 3 more things I need to show you, but it's all based around this same idea of realizing the patterns that appear in numbers. Once I know that multiplication is a pattern that's derived from addition, this becomes very easy. Here's what I'm going to do. I'm going to talk to you about just a couple properties very, very quickly that we can use to make this even easier and allow us to solve more and more complex problems. The first is the commutative property. It says, if the problem only has addition or only has multiplication, then the order doesn't matter. A lot of us probably know this property without knowing its names. In formal algebra terms, it says a plus b is equal to b plus a, or some unknown number or any number added to another number will give you the same answer if you change the order of those numbers. So for example, if I said to you 5 plus 3, you probably all know that that's an 8. But keep in mind that if I change the order, 3 plus 5 is also an 8. How about 4 plus 6 plus 2? Order of operations says we should do what first? Well, 4 plus 6 is 10, and 10 plus 2 is 12. Order of operations says we always work from left to right. Well, if that's the case, if I were to rearrange these, now I'm not adding the 4 and 6 together to get a 10. Instead, I've changed it. I've put the 6 first, the 2 second, and put the 4 last, which means I need to do 6 plus 2 and get 8, and 4 is 12. Notice that the order of these numbers had no effect on the solution because it's all addition. And if you think about that, it should make sense, because if these were piles of quarters, if I had 4 quarters and 6 quarters and 2 quarters, and I had those stacked in front of me, if I were to slide the 2 piles of quarters together and then slide the third in, it really doesn't matter which pile of quarters I put together first, I'm still going to end up with the same number of quarters. And I can also do this with negative numbers. Hopefully you're comfortable with negative numbers. We did that prior to this unit in my class, but hopefully you realize that if you have 14 plus negative 5, you get 9. And if you have negative 5 plus 14, you also get 9. So it doesn't matter if the numbers are positive and negative. As long as it's all just addition, the order doesn't matter. If you're uncomfortable with integers, I would suggest you go back and watch those videos prior to completing this one. Now, let's talk about what that means for us in algebra. If I have 5 plus some unknown number, even though I don't know what this number is, the commutative property says it doesn't really matter, because if I rearrange those, I'm going to get the same value. 5 plus 1 is 6, 1 plus 5 is 6, 5 plus 2 is 7, 2 plus 5 is 7. It doesn't really matter. I can rearrange those so it looks differently. Or how about this? X plus 4 plus x. This is one long string of addition, just like this example over here on the left was. Notice, though, I can't actually add an x to a 4. X plus 4 I can't do because I don't know what this number is. Ordinarily, I would be stuck here because order of operations teaches me I need to do the first two values first. However, the commutative property teaches me that it doesn't matter what order these numbers are in. So I can actually rearrange these and put the two x's together. Notice, order of operations said do x plus 4 first. I can't do that, but the commutative property says I can change the order of my numbers. That means if the x's are together, I can add those, one of them and another one makes 2 x's. Notice I still don't know the value of this number, but I have been able to combine things and make this problem a little shorter. As we work through algebra, you're going to find that as you do several different steps to make the problem shorter and shorter or simpler and simpler, you're going to find that you're going to be able to eventually figure out solutions that might have been hard to see in the first place. Tell you what, try this one on your own. Pause the video, see if you can come up with that solution. Hopefully you've already done that and you realize that you can't add 3 x's and a 7 because we don't know the value of these x's. But the commutative property says it's okay if we have this added to this added to this. Since there's nothing but addition here, I can rearrange this and put the like terms side by side. Notice the 7 and the 2x's changed position. I put the 2x first and the 7 second because I know that 3x's and 2x's can be combined to make 5x's. And then I just keep my 7. This is 5x plus 7. Now that's a lot, isn't it? That's only one of the properties we need to learn today. I've got a second one, but before we move on, I need you to make sure you understand what the commutative property teaches us and how it can help us. Once you're comfortable with that, keep right on going. The second property we're going to learn is the associative property, which says if a problem has only addition or only has multiplication, I can regroup the numbers any way I want. Or in fancy math writing, it says I don't necessarily have to follow order of operations if the operations are all just addition or all just multiplication. This one happens to be addition. Notice in this, ordinarily you would add A and B together, but I can regroup that and add B and C together without changing the solution. Let me give you an example. In elementary school, you probably had problems like 86 plus 57 equals 43. And using order of operations, we should have to add 86 and 57 together first. However, 86 plus 57 is not easy addition. When I look at this, I happen to notice that 57 and 43 are easy addition. So in elementary school, hopefully your teacher said, hey, you know what? Instead of doing those first two together, why don't we regroup this and do the 57 and the 43 first? Because it's easy to tell that those are 100. And 86 plus 100 is 186. By regrouping the easy numbers together, we made this problem much simpler and shorter than it would have been if we had had to add 86 and 57. Here's another example. This is probably from a higher grade. Ordinarily, order of operations says I need to do negative 19 plus 87 first. However, looking at this, I can look here and say, wait a minute, 87 and negative 87 are opposites. If I were to add those together first, this would be a much easier problem to solve. So I regroup it and say, hey, let's do 87 and negative 87 to get a 0, because negative 19 plus 0 is easy to work with. You get that negative 19. Now, some people get freaked out by these. These are called brackets. I'm using brackets just like I would parentheses as a grouping symbol. The reason I'm using them here is I already used parentheses here to keep my negative sign away from that plus sign. If we were handwriting this, sometimes they have a tendency to blur together, so a lot of people will put parentheses around just to let you know, hey, this is a separate sign. We don't like to use lots and lots of parentheses in the same problem, so I switched my symbols to brackets. A lot of times you might also see people use braces, which look like this. After I've used my brackets, if I had to do another set on the outside, I would use braces instead, just to make sure that I could tell what signs matched to what. Again, just be very, very conscientious and neat and organized. Those will always come in pairs for you. Let me switch back to my pen. Let's transition this over to algebra. In this case, order of operations says I need to add these two numbers together first, x plus 31. But I can't do that because I don't know what number x is. That would be a stopper for this problem. I would not be able to go any farther. But I happen to notice that this is addition and this is also addition. Since they're both addition, the associative property says I can regroup this. Instead of doing x and 31 first, I'm going to regroup it and do 31 plus 45 first and get 76. Now, even though x plus 76 is not solved, I still haven't found what the value of x is. Having x plus 76 only has one plus sign, whereas this one had two plus signs, so this is considered to be simpler. This would be called simplest form. I've taken everything I could and combined it together. You might want to pause the video and try this one on your own. I'm going to go ahead and go, assuming you've already done that if you wanted to. Order of operations says I should add the 35 and the x first. But I can't actually do that because I don't know what this number is. What I do know is that these are alike and they can be combined. So I'm going to regroup my numbers using the associative property so that I can combine the like terms. 1x and 3 more x's is 4x. Now, it's considered customary to put the x's before the numbers or constants. So all I did was use the commutative property at the end here to change the order. I put this first and this second. Remember, the commutative property on the last slide said as long as it's addition, the order doesn't matter. This is just considered to be more proper, and there are some reasons for that and some patterns that show up in later mathematics that helps with. So we have those two properties. We're going to put it all together now. We're going to try and do some cool things with this. These are going to get much larger, they're going to get much longer, but the principles or the rules that we use do not change. Here's our example. Notice I have 5x plus 3 plus 4x plus 9x plus 10. I've got several different numbers here. I have some that I know, like 3 and 10, and I have some that I don't know, this 5x. I have 5 somethings added together. I don't know what they are, but I have 5 of them. I have 4 of the same thing, and I have 9 of the same thing. Here's what I'm going to do. I'm going to take my commutative property that says as long as it's all just addition, the order doesn't matter, and I'm going to rearrange this so that the like things are together. Remember, I could not follow order of operations here because I did not know the value of x. But when I rearrange this, I now have all my x's together. That's called the commutative property. The order doesn't matter if it's all addition. The second thing I'm going to do is I'm going to use my associative property, and I'm going to group the things that are alike. I put a parentheses around all my x's, and I put a parentheses around all my constants, or just numbers. That's the associative property. Associative property says if it's all just addition, it doesn't matter how we group things. And then I'm just going to begin combining the things that are alike. I have 5 x's and 4 x's and 9 x's. How many x's is that? Well, that's 18 x's. Then I'm going to come over here. I have a 3 and a 10. That makes 13. In simplest form, this is 18x plus 13. Not too bad, right? These two properties together give you tremendous power to rearrange and regroup problems in algebra. The better we get at rearranging and regrouping, the easier everything becomes down the road. Try this one on your own. Again, pause the video, use the commutative property to rearrange, use the associative property to regroup, and then restart the video to see if what you did matches what I did. Remember, commutative property says rearrange. So I'm going to take the things that are alike and I'm going to put them together. I'm putting my m's, my 7m's and my 15m's together. Then I'm going to take my n's and put those together. And then I'm going to take my numbers or constants and going to put them together. Since it's one long string of addition, it doesn't matter what order I put those in. I wanted the things to be together. I want them together so I could use the associative property and regroup them. Again, I'm just putting my m's together, I'm putting my n's together, and I'm putting my constants together. Because now I can use just some simple addition to figure this out. I have 7m's and 15m's. Well, that's 22m's. And 9n's and 12n's makes 21n's. And 8 plus 11 make 19. I don't know why I didn't put parentheses around these. You could put them there if you want to. In all honesty, all those parentheses are really unnecessary because there's nothing really to group inside of there. But I'll write it out like this, and I'll put a little box around it so it's easy for my teacher to see. Now, a couple quick notes for you. You will notice that my tendency is to do the commutative property and the associative property separately. If you were in my classroom, I would actually make you write this problem out of your textbook. Then I would make you write the commutative property, write the associative property, and then combine things. And then I actually probably would let you skip this step and jump straight to here if you wanted to. So you would have 3 or 4 lines of writing in my class, at least the first couple of days. And if you're a teacher, I would highly encourage you to do that because it helps the students know why they're doing certain things. It also keeps them from making careless mistakes. However, after a few days, I would begin allowing you to combine these steps into one. So you would rearrange and then you would put the parentheses in on the same line rather than having to do it in 2 steps. And then eventually, as you got better and better at this, I would allow you actually to jump straight from here all the way down, just using some organizational tips and strategies that we'll talk about a little farther down the road. But for now, it is good practice, a good habit for you, especially if you struggle with keeping track of things and have sloppy handwriting, those sorts of things. It really is very useful for you to show all these steps. I would typically not make my pre-algebra students write commutative and associative every time. I would continue to ask those in words in class. If you were in my Algebra 1 class, you would actually have to not only make the change, but you would have to justify it with the property as well. So you might as well go ahead and learn those now because it will come up in the future. Tell you what, one last thing I need to make sure I show you, and then we are going to call it a day. Notice that this example has a subtraction sign in it. If you remember from our integers unit, I tend to avoid subtraction at all costs. You will find in Algebra 1 that minus signs and negative signs will give you more trouble than basically anything else. And a lot of students who think they're bad at math actually aren't bad at math. They just struggle with keeping track of signs, so they get problems wrong and then begin to believe they're bad at math. My suggestion and my requirement, if you're in my class, is anytime you have a subtraction sign, change it to adding the opposite. Add the opposite. That goes back to the definition of subtraction, and we talk about that quite a bit in my integers unit. Subtracting is it just gets to be confusing. Also keep in mind that the commutative property says that if all I have is addition, then I can rearrange and put things together. If all I have is addition, I can rearrange and put things together. The commutative property does not apply to subtraction. So you have to be very, very cautious when you have subtraction. By changing this into addition signs, I just make it a whole lot easier. Again, we've done the hard part. Commutative property to rearrange, associative property to regroup, and then we simplify. That's your final answer. For some reason, I left this as an M. That actually is a typo. Those should be X's. Remember, the variable you use doesn't matter, but you do need to make sure that you're consistent and using the same variable throughout the entire problem. Again, pause the video, try this on your own. I'm going to assume you've done that, and I'm going to do this one a little faster this time because you should be getting much, much better at it. I use the definition of subtraction to get rid of all my subtraction signs. Notice I made them into plus negatives. I'm going to use the commutative property to rearrange all my y's and my commutative property to rearrange all my numbers. Notice that I combined this into a single step now, and I went ahead and did my associative property as well. As you get better and better at this, you're going to find that you can do that. And then I'm going to combine my like terms. 1 plus 2 is 3y's, plus negative 5 is negative 2y's. Negative 3 plus 7 is 4, plus 5 makes 9. And then I just wrote it real nice for you. Feeling good? This one looks a little different, but you use the same principles. Again, I'd recommend pausing it and trying it on your own. I'm going to assume you've already done that. You change your subtraction to addition. Notice they all became plus negatives. And this time when I regroup my like things together, it's important for me to realize that x squareds are different from x's. If this was 3 squared, this number is actually a 9, whereas this would just be a 3. If x was a 2, this would be a 4, whereas this would only be a 2. If x was a 5, this is a 25, whereas this is a 5. 6 25s would be different from 6 5s. So I can only put these with other x squares. Plus, I'll do the same thing with my x's. Notice that I have 3x plus negative 2x. That's 1x plus negative 1x. Wow, this is really, really bad. There's another typo here. I'm going to add my plus 3x into this one. Those are my like terms. Notice negative 2x plus negative x makes negative 3x plus 3x. This is going to be a 0x. Oh, how cool is that? Over here, 6x squared plus 11x squared is 17x squared, but we just said, since I forgot this 3x, that this is going to end up being 0x's. The final answer is just 17x squared. It is possible for things to come out as 0 or none. I'll go back and fix that in my slideshow. Last one, again, pausing the video, trying this on your own. I'm going to keep going, assuming you've done that. Get rid of the minus signs. I can't stress that enough. Change them into plus negatives. Once you've done that, rearrange so your like things are together. Notice that I have 1w cubed plus 4w cubed, that's 5, and negative 9 makes negative 4, plus negative 7 makes negative 11. Notice, instead of rewriting this in order with the commutative and putting the parentheses around it with the associative, I've begun to take the shortcuts that you would want to do after doing this a few days. Again, be careful. Take the time the first few days to do the rearrange and rewrite, but as you get better and better, you can begin to take these shortcuts. Notice I have 2v squared. That's the only 2v squared there. There's nothing for me to combine it with. And over here on the left, I have 1v and nothing to combine it with. And now here on the far right, I have 6w's and there's nothing to combine that with. My answer is just all of those written down. And again, there's another typo. I'll go back and fix that as well. Notice that I've got a typo here as well. Your final answer should be negative 11w cubed plus 2v squared plus v plus 6w. And I can put a box around that now. Hopefully that was helpful for you. Hopefully my typos didn't throw things off too much. Keep in mind that as I began to take my shortcuts was where I began to lose track of things and start to make those typos. That is not an accident. That actually is what will happen to you as well. That's why it's so important to make sure that, especially early on when you're doing these, you take the time to write out all those steps so you don't begin to make those careless mistakes. Fortunately, I've been doing this for many, many years, so when I make mistakes like that and I start to record this video, I can spot those and it saves you the trouble of pointing them out for me. As a early learner or beginner in Algebra 1, the more shortcuts that you take, the more likely you are to make those kinds of errors. So please be cautious about that. I hope this hasn't been too long for you. I really do appreciate you taking the time to watch with me. I do wish you all the very, very best of luck. Make sure you like and subscribe and ring that bell to turn on your notifications so you can see when our sequels to these lessons come online. As always, take care of yourselves. Bye-bye.